We're going to be moving on to the next example. The next example of what we're going to be doing here is, now let me just get my cursor. Here is given the function f of x is equal to x squared. F undergoes various transformations as described by y is equal to 3 f, open brackets, 5x plus 2 minus 1. Our first order of business here, I'm going to call this number 1, is we're going to write in the transform formed this. All right. On first appearance, definitely a is equal to 3 because that's what's multiplying my function f. Now, we have to be careful. The coefficient in front of the x is not 1, it's 5. So we're going to have to factor out that 5. And by the way, this looks like it's k. So this, number 2, will be affected by when we factor out the 5. So allow me simply to write 1, y is equal to 3 f 5x plus 2 minus 1. So here, y is equal to 3. I'm going to factor out that 5 just to see what it looks like. Switch up the color of my pens to make it obvious. 5. If I factor out 5 from 5x minus 2, keep in mind that factoring out is like dividing, would be x plus 2 over 5, close brackets, double brackets, minus 1. My brackets should match up, and they do. So this is in transform form. Now let me go to the second part of the question. Write in regular functional form. So I could write this in regular function form. Now, this is transformed function form. My parent function, though, is f of x is equal to x squared. Sorry about that. So if we are going to write that in the form, so here, a is equal to 3, b is equal to 5, h is equal to negative 2 over 5, and k is equal to negative 1. So if I write the regular function form, now what I mean is write this as a quadratic because the parent function is a quadratic, it would look like this. Y is equal to, we have a few options. I'm going to build it up in several steps. I'm going to take care of this a first. Y is equal to f of x was x squared. Then first thing I'm going to do is I'm going to put that a in front. Y is equal to ax squared. Oh, pardon me. It was a little bit too, that wasn't good. It should be y is equal to 3x squared. And then I'm going to add the 5 in there, or include the 5, I should say. So y is equal to 3 times 5x squared. Next thing I'm going to do, I'm going to include a horizontal shift. Y is equal to 3, 5, x plus 2 over 5 squared. Last but not least, k is minus 1. Y is equal to 3, 5x plus 2 over 5 squared minus 1. So that's the look of my parabola here. And obviously I could multiply this out and make it a little bit prettier, but I'm not going to do any more work than I deem necessary, particularly with this. So allow me to go down to this next one. Example. Given the function g of x is equal to 1 over x, it undergoes various transformations as described. Y is equal to negative 2g, open brackets, x plus 2 minus 1. We're going to identify the values of a, b, h, and k. So from this, I get a is equal to negative 2. B is equal to 1. There's no coefficient in front there. H is equal to negative 2, and K is equal to negative 1. So again, I could build this up. Now, you have to be careful. if you want, you can press pause and try to come up with the answer yourself. Okay, I believe this is the final answer. Y is equal to negative 2 x plus 2 minus 1. That's what we'll end up with, right? But instead, I'm going to build this up. I'm going to start off with my parent function. Y is equal to 1 over x. Then I move on to the next. I'm going to try to multiply by negative 2. So if I multiply the function by negative 2, or it become y is equal to negative 2, 1 over x, which really is y is equal to negative 2 over x. The next step is I'm going to take care of this h. Now the h is negative 2, and this is always what happens. So here I'm just going to write this, y is equal to negative 2x. And I'm going to put the x for some reason in brackets, but it just helps me with this next step. Remember, I know what to do, but the most important thing is to try to avoid errors. So if h is equal to negative 2, this is what it looks like in brackets. Now last but not least, I am going to include the parameter that k is equal to negative 1. So here, y is equal to negative 2, x plus 2. So that was my function up there. And simply, all I have to do is include k, which is subtract 1 to the function. I hope that helps. I'm building this systematically, being very, very careful not to mess this up. Now, just a brief note. Although I have 3 parameters, there's actually 4 different transformations. 1, it would be a reflection in x-axis, right? If we were asked list all the transformations, we'd have to include the reflection. And then we would say stretch by a factor of, now I'm going to put the absolute value of negative 2, but really we would stretch by the factor of 2. Often that's forgotten. And here, obviously, for h, we would shift 2 units to the left. K would shift 1 unit down. But this is what I really wanted to talk about here. We have to be careful about when A is or B are negative. Now, I'm going to go over to the last example here. We're going to graph the graph of the function y is equal to g of x represents the transformation on y is equal to f of x. So determine g of x in the form. So I guess perhaps this is a lot of words. The graph of y is equal to g of x. So this represents a transformation of the graph y is equal to f of x. So this is transformed to become that. Determine g of x in the form of y is equal to a, f, open brackets, b, open brackets, x minus h, close brackets, plus k. Describe your reasoning in words. So if you want to take a chance with this by yourself, by all means, get started. And here we go. I guess we need to pick out A, B, H, and K. Now, the most important thing here is we have to do A and B first, and they are going to be independent of each other. So you may be asking, like, Mr. Morin, what are you talking about? Well, we need to see if this was vertically stretched. Now, I would encourage you to ignore the background here. And I'm going to pretend like there's no axis initially. What I notice is, if I can call this tall, really what you want to do is you want to pick out signposts, a really important point. I notice that this is 4 tall. That's my parent function. However, my transformed function, the resulting function, is going to have to be 8 tall. Now, how wide is this? Well, this looks like it's 4 and 4, so I guess this is 8 wide. And now, here, this is 2. The reason why I'm focusing on A and B, it appears like, anyways, is because we have to do these transformations first. If you decided to stretch, if you decided to shift it, you may come to a different conclusion. It would definitely be wrong. But here, A, how do we go from a vertical sort of climb of 4 to 8? Well, it's simple. You would multiply by 2. You would stretch it by a factor of 2 vertically. Right? Maybe I'm in words. I would say stretch. Pardon me, that's spelled wrong. Stretch by 2. And I better put vertically stretch, right? Vertically stretch by a factor of 2. Now, for B, what do? Horizontally, we went from 8 to 2. In other words, what is B? B is 4. Now, the nice words to go along with this is, I forgot, horizontally, compress by a factor of 4. Also here, to describe the horizontal movement, you can say we stretched by a factor of 1/4, which is also true. Now H and K, now I take a point. Now this point is really important, right? You might come to a wrong conclusion if you said, I'm going to move this point all the way over here. Maybe to get the proper H and K, and it is quite difficult, by the way, you may want to make a quick sketch of the transformed graph. Now I'm going to talk about that highlighted point later. So I'm going to stretch this by a factor of 2, it becomes 8. Compress it by a factor of 2, becomes, right, 8. Compress it by a factor of 4. There's my new curve. Now this is only an intermediate curve, and I know it's not a curve, it's more of a V, but all graphs can be described as a curve. I know it's weird, like even linear lines are curves. There. So that's a quick sketch, and by the way, this quick sketch looks awesome to me. So how do I get this into that? Well, I would simply move 1, 2, 3, 4, 5, 6, 7. 7 over to the left. So H is -7. And I would move 1, 2 up. K is equal to 2. So describe your reasoning into words. You can simply say I would move my transform graph 7 units over to left and 2 units up. You could describe the transformations. Now, very quickly, and I'm sorry I'm taking so long, what is so incredibly important about the origin in transformations? Well, if a point at the origin, no matter what the transformations for A and B occur, a point on the origin will stay as a point on the origin. So it's a really good reference point for after then you want to shift it. Anyways, I hope this helped. All the best.